maneuver that is taking place, although barely perceptible, by the robotics officer here in Mission Control to what is known as the pre-install position, will then be followed in kind with the actual installation work, in which the robotics officer will continue to maneuver the Canadarm2 in the firm grasp of HTV-4 into the pre-install position. Along the way, there will be varying checkpoints. You can see this view through a camera that is known by the acronym of CBCS. That's the Centerline Berthing Camera System. This provides visual cues for the robotics officer here in Mission Control, John Bellingham, to be able to monitor the alignment of the common berthing mechanism, the passive side of it on the HTV spacecraft itself, with the active common berthing mechanism on the Earth-facing side of Harmony.
On fill station on station round 2.
Go ahead on 2.
Just wondering if it's okay for me to pick up in the MSG activation.
Karen, you bet it is. Go for it.
You're looking at varying views from both external cameras on the International Space Station and the Centerline Common Berthing Mechanism camera, views that are being provided to the robotics systems officer here in Mission Control as the maneuvering of the station's robotic arm continues to align the HTV-4's common berthing mechanism with a similar berthing mechanism on the Earth-facing side of Harmony. We're not quite there yet. This is a very deliberate maneuver, very carefully choreographed on the ground so that we have a precise alignment between the two berthing mechanisms in what is known as the ready-to-latch configuration that will enable the crew on board the station initially, followed by ground controllers here in Mission Control to bolt the HTV-4 in place.
The MSG is activated, and I'll be ready to pick up in the operation of test perimeter 103 or test 103 whenever you guys would like me to.
And Karen, you have a go to proceed.
Thanks.
Here in Mission Control, it has been confirmed that thrusters have been disabled on the International Space Station, and the robotics officer now will press ahead to move the HTV-4 inside 2 feet of the berthing interface with the Earth-facing port of the Harmony module. And a view from the centerline common berthing system camera that again is providing alignment views for the robotics officer here in Mission Control, John Bellingham, as he works to precisely align the HTV-4's common berthing mechanism with the comparable twin of that CBM on the Earth-facing side of Harmony.
Go ahead.
And the square wave generator mode was to standby at 1401.
That's full copies. Thanks.
A good view from a camera on the truss of the International Space Station showing HTV-4, 30 feet in length, 14.5 feet in diameter, 16.5 tons in mass, hovering over the common berthing mechanism on the Earth-facing side of Harmony. The International Space Station flying 260 statute miles over the South Pacific, about to enter an orbital sunrise. Here in the flight control room, the robotics officer, John Bellingham, has reported to Flight Director Judd Freeling that they are working to fine-tune the alignment of the HTV-4 berthing mechanism with that of the Harmony module, to which it will be attached a short time from now. Housed aboard the HTV-4, some 3.6 tons of cargo, 4,100 pounds of dry cargo inside as pressurized volume, as it is called. That is comprised of spare parts and experiment hardware and supplies for the International Space Station Flight Control Team and crew. Some 24 bags of water, about 1,300 pounds of water in all, and externally as unpressurized cargo housed on an exposed pallet, as it is called, in a side slot on the body of the HTV itself, 2 critical spare parts, a main bus switching unit and a utility transfer assembly unit, and a suite of experiments for the Defense Department called the Space Test Program 4 experiment for the Department of Defense's office here at the Johnson Space Center. Those spare parts and the Space Test Program payload will be affixed to varying points along the truss of the International Space Station, the spare parts to be used if required in the future, the Space Test Program to spend several months acquiring data on the effect of the microgravity environment on samples of materials. Having passed into an orbital sunrise, the International Space Station, with the HTV-4 hovering just a short distance above its destination, that being the Earth-facing port of the Harmony module, moving from northwest to southeast, approaching the southwestern coast of South America, soon to cross over the Andes Mountains, and then swing back across the South Atlantic on this particular orbit of the Earth. The robotics systems officer here in Mission Control continues to align the HTV-4's common berthing mechanism with the similar mechanism on the Harmony side of that berthing interface so that we can move into a ready-to-latch position and begin the bolting of the cargo ship into place.
I'm still stationed on Station Ground 2.
This is Huntsville. Go ahead.
I am complete through step 4-8. Just wondering if you have good views on the ground of this, or if you need any description of what I'm seeing.
And Karen, the in-space PDs are happy, so you have a go to press. But thanks for checking with us.
All right, I'll give it 20 minutes and then come back for step 5.
That sounds like a great plan.
To recap the morning's activities, a flawless rendezvous for the Japanese HTV-4 cargo ship to the International Space Station. All of the rendezvous maneuvers were executed in fine fashion with no issues and no systems problems reported at all. The HTV-4 arrived about 1,000 feet directly below the International Space Station, slowly but surely executed all of its rendezvous burns to maneuver its way up the so-called R-bar, the radial vector, that being the imaginary line that is drawn between the International Space Station and the Earth. It inched its way up the R-bar to a point just 30 feet away from the station, stopping at varying checkpoints to enable its systems to be monitored to ensure that it was in a good configuration for its ultimate capture, at which point Karen Nyberg, operating from the cupola workstation, the robotics workstation in the cupola, maneuvered the station's Canadarm2, reached out and grappled the grapple fixture on the HTV-4 cargo ship. A firm grasp initiated between the robot arm's latching end effector and the HTV-4 grapple fixture itself. At that point, she turned over the robotics activities to the robotics ground control team here in Mission Control, led at this hour by the Orbit 2 team Robo, as the position is called, John Bellingham, who maneuvered HTV-4 into an inspection position Everything was found to be in good shape with its common berthing mechanism, no foreign object debris, and nothing that would preclude a smooth installation of the HTV-4 onto the common berthing mechanism on the Earth-facing side of Harmony. You're looking at a view right now as HTV-4 is hovering just above that common berthing mechanism as Bellingham is working to precisely align the two berthing mechanism interfaces between the HTV-4 and the Harmony module before moving it into a ready-to-latch position for the bolting of the cargo ship into place. This is Mission Control Houston. Here in the flight control room, the robotics officer is going to take a break for just a few minutes while we wait for a handover between our tracking and data relay satellite system and the ability to have a downlink television capability from the station that will provide the views that you're looking at through the centerline common berthing mechanism system. This alignment process requires a video capability, so the robotics officer here in Mission Control can monitor the alignment of the common berthing mechanism on the end of the Kounotori 4 or the HTV-4 cargo ship with the common berthing mechanism on the Harmony module. We're getting close. Again, a slow and methodical process at this point to provide a fine alignment, a precise alignment that will enable the HTV-4 to slip into the capture envelope of the common berthing mechanism, provide a ready-to-latch indication for the crew on board the station that will be their cue to begin bolting the HTV-4 in place. They will conduct the initial bolting, the A-bolts as they are called, for a first stage capture of the HTV-4 from a laptop computer aboard the International Space Station, then hand the process back off to the flight control team here in Houston, where the operations and support officer, the mechanical systems officer, if you will, here in Mission Control, will complete the bolting for the second stage capture that will firmly mate the HTV-4 in place at the International Space Station.